Well, I'm very honored to have received this award today, and I'm going to start, because this is the first time that this award has been given, I'm going to start by telling you a little bit about the man for whom it's named. I'm going to try to do that anyway. Let's see. There we go. Greg's career began at the Solar Energy Research Institute, which is now the National Renewable Energy Laboratory. He was on the board of directors of the American Solar Energy Society, a member of the College of Fellows of the American Institute of Architects. He was the co-founder and 1994 chair of the AIA's National Committee on the Environment. He received the U.S. Green Building Council Honor Award, and he received an AIA Presidential Citation. At the last part of his professional career, he was working in a very prominent position with the Rocky Mountain Institute, Amory Lovins and colleagues, and was leading major projects. The last major project that he worked on was the renovation of the Empire State Building in New York City, where they saved an enormous amount of energy by an integrated design approach. And of course, as was said earlier, Greg was the chairman of the Sustainable Buildings Industry Council. One of his colleagues at Rocky Mountain Institute, Victor Olgay, said this about him, and I thought it was one of the most profound statements about Greg's work that I've seen. One of the projects that Greg and I worked on together was the greening of the White House when President Clinton was our president, and we got to know President Clinton at some level. The last thing that Greg was working on at the time of his untimely death was a book called Cooling the Warming, in which he was addressing this whole issue of climate change and the opportunities that we have as architects to make better buildings and better communities so that we in fact address these issues. President Clinton said this about Greg in the introduction to that book, and his colleague Amory Lovins called him the world's leading integrative architect of super efficient, beautiful, and delightful buildings, which is a great way to say it. Now, many of you know that buildings are responsible for a lot of the environmental impacts that we experience. 48% of total energy use, 76% of our electrical consumption in the U.S., and many other attributes. What that means for us as architects is we have lots of opportunities. It's a big target, and we can make big improvements when we approach design in the right way. But the topic we're addressing here today is beyond green. So it's these and more things. And when we talk about high-performance buildings, we're talking about buildings that address human, environmental, economic, and total societal impact, and look at these 8 topics. So in the presentation that I'll make showing some of our firm's work, and in the other presentations that you will see, you'll see a strong emphasis on sustainable design, but you'll also see an emphasis on the other elements that make high-performance buildings. So I'll start by talking about a building we completed for another institution with a School of Architecture, Rensselaer Polytechnic Institute. For them, we did the Center for Biotechnology, which is a gateway campus building that responds to climate and advanced science requirements. This was a project that we collaborated with our friends at Boland Sawinski Jackson on. And we created lab space that is very safe for the researchers, productive, meaning that they're able to really do advanced science there, highly collaborative, and flexible so that as research needs change, the labs can be reconfigured so that they are timeless. They, in fact, will last a very long time, even though science changes. We created a central atrium space that provides daylighting and also creates circulation and meeting spaces. We customized the glazing to address the solar gain in that space. And then we went a step further. Instead of conditioning that atrium space, we used natural ventilation. And by doing so, we were able to eliminate a mechanical cooling system for the atrium. That meant we saved about $1 million in first cost by not having to put that mechanical system in, and all the energy that would have been used by that mechanical system for the building's life. So look at climate. Look at the opportunities that you have in a particular climate and see where you have the opportunities to do things like this. More and more we're seeing buildings where natural ventilation is an important element of design. This is a bit of a different project in Boston. This is a transit-oriented development, a condominium project in South Boston that received both a LEED Gold Award and also from AIA Top 10 Committee on the Environment Award, as well as National Housing Design Awards. And one of the attributes about this building that's very interesting is that it makes use of a green roof that both moderates climate and manages rainfall, reducing the runoff to storm sewers. Taking it to a community scale, this is a project in South Carolina. It's called the Noisette Project, and it is a LEED for Neighborhood Development pilot project. This entailed the conversion of a former naval base to create a sustainable urban place that's really based on triple bottom line principles. Triple bottom line meaning we're addressing economic, ecological, and social design principles in what we do. And there's a number of elements that we had more time we would talk about in this design. So taking something that's old and making it new, but making it part of the fabric of an existing city. We also created the office space for the headquarters of the Noisette Company. This was in a historic warehouse on the Navy Yard. It was built in about 1905, and we took that warehouse and converted it to day-lit offices that are highly productive. This is a LEED certified project under the Commercial Interiors program. You can see there's a very high quality of daylighting and lighting here and a very collaborative kind of working environment. A little closer to home, this is in Baltimore, actually Woodlawn, just outside of Baltimore. This is the Social Security Administration, about a 1.2 million square foot building. And this was a renovation, an interesting project because it was originally a computer operations center. Because they had lots and lots of computer equipment, they didn't figure that they needed much in the way of windows. So the footprint of this building, each floor is equal to 6 football fields, or putting it in the context of football stadia, you take 2 of the Baltimore Ravens stadia, not just the field, but the entire seating area. That's how big this floor plate is. So it's huge. If you're trying to make this a place for people, what do? Well, you start to look at ways in which you can introduce daylight, introduce logical ways for people to be oriented, providing a sense of interior streets and creating orientation, as well as bringing light to adjacent spaces. We went a step beyond this, though. We also created this building as a model of ADA accessibility. It goes way beyond the requirements of ADA, and by using extra wide aisleways, cart charging stations, and a variety of other techniques, this is a truly accessible building, far beyond what the code requires. It's also a LEED certified building. We had our presentation this morning on the House side of Capitol Hill. This is a building that's in the historic district on the Senate side, so just on the other side of the Capitol. This was a building we designed for the Friends Committee on National Legislation, a historic building that we converted to a LEED silver carbon neutral office building. We used a number of techniques here. Lighting was very important. We also used a geothermal system to provide the heating and cooling of the building. So it's an all-electric building. All of the electricity is provided by wind power. That's why it's carbon neutral. One of the elements that was important is to bring light into the center of this building. So we designed a light scoop and a glass floor to bring daylight down through the building. So the light that's admitted here cascades down through the building by using glass floors beneath the light scoop. And if you were in the Hart Senate office building and you were looking out the window on the east side of the building, this is what you would see. The idea here was to make the building a symbol of what the Friends Committee on National Legislation has as their principles. And one of their principles is we seek an earth restored. So if you make the building speak to that principle, you send the message even when people are not in the building. Going to a little bit different location, this is a large hospital project in Abu Dhabi. Our firm practices in India, in the Middle East, US, and Canada. And so this is a project that is a 700-bed hospital. It's currently under construction. It's based on Estadama sustainable principles, and it makes very careful use of daylight. Abu Dhabi is a very bright place, very hot in the summertime. I've been there lots of times in the summer. And so you really have to control daylight in some pretty careful ways. But you can, in fact, make wonderful space and also contribute very much to the healing process. So by the way in which we bring light into the building and some of the techniques that we used to be able to save energy, we were able to create great space here. So one example of that, if you think about a healthcare environment, you want to maintain infection control. We wanted to be able to exchange heat between the incoming air that's used for ventilation and the outgoing air that's for exhaust. So rather than using some of the conventional technologies that might have allowed those air streams to mix, we used a heat pipe technology that uses a passive refrigerant to transfer the heat between those two streams. So there's no contamination because the air never comes into contact with each other, but we're still able to achieve a very high efficiency of heat transfer and therefore save energy. I'm going to close with one more project. This is a research support facility for the National Renewable Energy Laboratory. And I thought it was a fitting project to close because, if you might remember, one of the first things I said that Greg Franta did was to be the leading person for commercial buildings, for passive solar commercial buildings, when NREL was the Solar Energy Research Institute. That was in the early 80s, and if he were alive today, I think Greg would be extremely proud of this building. It's a 220,000 square foot net zero building. Net zero means that on an annual basis, this building produces more energy than it consumes. This is the largest net zero building in the U.S. at this point. You're going to see some other great examples today of net zero buildings from some of the other presenters, but we're proud of this one. It also creates some beautiful lighting within the workspaces and some great spaces for people to be productive. This is on track to receive a LEED Platinum Award. So in closing, I want to thank the jury, the SBIC, for this honor of receiving the award for Greg. I'm honored to have been his friend. I'm honored to have had the opportunity to work with him on many projects. He was a great leader, and I'm very proud to be here today and to have the opportunity to speak with all of you. Thank you.